prospects and challenges. It's a very high level talk, not really going into technical details, and then later on I'll touch briefly upon some of the work that we are doing. So I think I'll skip some of the initial things, but one of the things that I was just having discussion with our colleagues, I would just like to draw your attention to certain things and certain facts. One is that if you look at who is consuming most oil, so here we have United States, which consumes about 26% of the oil with 300 million people. India is 2.6% of the global oil, with four times population. Okay, which means that per capita energy consumption is 140th. That is one factor that we have to keep in mind. 140th. Since 1850 Industrial Revolution, we have had almost 16, 17, 18% of the global population, but our contribution to the net GHG emissions so far has been less than 4%. That's another fact that we have to keep in mind. So the West, Europe, and America, they have used hydrocarbon sources for achieving the level of development. India has not. So we were talking about coal phasing down. I think we still are a long way from parity per capita CO2 emissions, per capita energy consumption. And we all know that energy consumption is related to development, human development index in some sense. We can't deny the progress, we can't deny the right of mobility to our people. The whole earth belongs to all of us. So that's one political point that I wanted to make here. Having said that, I am not saying that we should be polluting, we should be putting more CO2 emissions. We should not. We should try to control it. But then when we say we, it means everybody in the room. If you look at the energy consumption, so this is a story for 100 years. The story is that your energy consumption grew by about 4%, then it grew by about 30%, 3%, and then now we are somewhere here, where our petroleum resources are going to be plateauing. And then after some plateauing of 5-10 years, they will start coming down. But our demand will keep rising. So how do we meet that demand? So the demand will be first met by gas. So all countries have started adopting to natural gas, hydrogen, and so on. But the natural gas also has finite sources, so it will also plateau out. And then we will have to go for ammonia, hydrogen, e-fuels. So practically that leaves us, this is about 2035, 2040. That leaves us with 15 years as scientists to develop solutions which are economically feasible. And we should be able to provide fuels at an economic price to compete with fossil fuels. Until then, fossil fuels, I mean, you like it or not, they are going to be there. You can't do away with them. The sustainable transport is a very busy space. There are a lot of players. For example, it directly is affecting the economy, it directly affects the employment, it has social impact, it has environmental impact, it has economic impact. I don't want to go into details, but this is very important that we go for sustainable transport. That's objective towards which every country in the world should work. This is one slide that I have taken from Volvo, and they provide a lot of transport solutions, and they propose that whenever we go for a new fuel, we have to look at these 7 factors. The impact on the climate, energy efficiency of the new fuel, land use efficiency, fuel's potential, how much you can produce, vehicle adaptation, how much hardware changes, software changes required, cost of the fuel and fuel infrastructure. So any new fuel you propose, you have to evaluate them. And then, if you look at the sustainable fuel, it's an extremely busy space with a lot of options coming: methanol, ethanol, hydrogen, synthetic diesel, biogas, biodiesel, and so on. And all of us agree on this, that at least in future, the fuels would still predominantly continue to be liquid fuels. They will still be made in refineries. E-fuels also have to come in some way into the refineries, use the refinery infrastructure. Why they will be liquid fuels? Because there's nothing which packs more energy density compared to liquid fuels. They are very easy to store and handle, and there is extensive distribution network. We can't have a separate distribution network for any near fuel we propose. Now, if you look at the 21st century, this is the number of vehicles on the y-axis and the years, 50 years story. So I think if you look at this, this is America and this is Europe. So 1970 to 2010, 2020 was the growth story of America and Europe. America right now has 950 plus cars per 1,000 people. Europe has approximately 700 cars per 1,000 people. India has 27 to my last count. Sakti will correct me, 27 per 1,000 people right now. So we have very little motorization, and we are just beginning to motorize and give personalized transport. So look where the action is. The action is in this triangle. And this triangle actually is China, Asia and India. So this is where the global growth is going to be in next 20-30 years. And actually that is why Asia or India and China are big saviors. They are, in these times of economic depression, they are the engines of growth for global economy. And this is where most of the action will happen. And we have to do it in a responsible way. So if you evaluate, excuse me. So if you evaluate these fuels on the 7 factors which I just discussed, the darker one is optimal, the white one is less optimal, and you can see this here, that in this entire sustainable fuel, what stands out is one is DME, you can see these dark green patches here. Then methanol also stands out. EVs also stand out, but 2 patches are completely white, which is basically the fuel infrastructure and vehicle adjustment. It is a negative there. So you, from this table, actually you can figure out the future of each fuel, how it is going to be. So in India right now, we are actually focusing on 4 important things. One is the ethanol economy. Our economy already has 12% penetration of ethanol, and we aim to bring it to 20% by 2025. We are pushing for methanol economy because we have a lot of coal reserves, and mostly 80% of our coal is high ash coal, which we can't burn in power plants, which we can't burn in steel industry. So we are pushing for methanol economy by gasification, produce carbon to syngas and syngas to methane. And in this whole process, you don't put any CO2 into the atmosphere. So this is one good way. And of course, government has already committed to spend about $3 billion in hydrogen economy. We plan to have $1 a kg hydrogen production target in 10 years. And then we are also pushing battery electric vehicles in a big way. So these are the 4-pronged approach which Government of India has taken to tackle and to actually comply with our net zero, move in that direction. You know, this is just the beginning. So I'll talk about methanol. So methanol has, 3 P factors are very important in methanol. One is the production. Production cost of methanol in India is very, very low. When I say per unit energy production cost per megajoule, it is roughly about 25% to 30% compared to fossil fuels. So it has a lot of economic advantage. The refinery guys don't like it, but that's, and so price, production and pollution. Pollution is also very low in methanol. So these are all plus points. Now, when we want to adopt it in the engine, we have to look at the properties very carefully. So if you look at the properties, one thing that stands out is this: methanol has very low calorific value, which is approximately half, and then you have higher latent of vaporization, latent heat of vaporization. So accordingly, you have to tune your induction strategies and so on. And then also, now I'd just like to share a Chinese plan. Chinese are big on methanol. So what Chinese are trying to do is, they call it fossil sunshine, and they say methanol and DME both e-fuels. Actually, methanol and DME are two sides of the same coin. You take 2 methanol, dehydrate them, remove water, you are left with DME. Methanol is a good fuel for SI engine, DME is a good fuel for CI engine. Now, what Chinese guys are doing, and it's purely economic. The government is not supporting. Here in India, government is supporting this. In China, no government support. It's purely economic reason. And they have more than 2 million vehicles running on methanol. So what they do, they also have a lot of high ash coal. They convert that and they run all the taxis and vehicles which run long distance every day. Purely because it costs less. And so what they plan to do is that they will implement this. They have already deployed this technology in a large scale in their economy. They want to make it clean. In order to make it clean, they will shift from coal to gas. And then eventually they will shift to biomass. So once you are in biomass, obviously the fossil CO2 will not be put into the atmosphere and it becomes cleaner. So by 2040 they want the first deployment and mass deployment of this biomass to methanol conversion by 2050. And then by 2050 what they also want to do is that they want to create the electricity from CO2 free sources, solar and wind, use that electricity to split water, generate hydrogen, capture the hydrogen from the atmosphere, capture the carbon dioxide from the atmosphere, react it with hydrogen and produce CO2. Produce methanol, what's happening? So this methanol, the first technology demonstration commercial plant, they have targeted 2050 and then large scale will be 2070. That's their plan. And I think it makes a lot of sense. And it makes a lot of sense for us in India to follow a similar path. Not everything Chinese is bad. They are doing a good strategy. At least we can tune it to our needs. Alcohols, if you look at the alcohols here, we have compared the properties of the methanol with ethanol, gasoline and diesel. And again, here you see the methanol has very high latent heat of vaporization, half this. And here the comparison is done for energy density, storage cost, transport cost. And in all these factors, methanol and other alcohols scores much better than battery electric vehicles. Now, methanol can be used as DME and methanol itself. Methanol has a high octane number, 100 to 105. DME has very high cetane number, up to 70 to 75. So you can use it in variety of ways. For example, you can use straight in the engine. You can use them in fuel cell. You can convert them into hydrocarbons. Yesterday, Dr. Alok Sharma was showing that, how you can do it. And you can actually run the DME diesel engines. So you can practically run the entire array of transport sector, whether it is small vehicles or cars or ships or, buses, trucks on methanol and DME. And in addition, we can also we import a lot of LPG for our cooking. Now this DME can also be used for cooking purposes. So it can not only take care of the transport, but it can also take care of the cooking. But the limitations of methanol are the lower calorific value, so the range of the vehicle will be less, half. And then they can produce formaldehyde emissions. And they are not completely, they are completely miscible with water, so if there is any accidental spill, they can cause some flora and fauna damage. But the good news is that in water it degenerates very fast, so it will get diluted out and it's more corrosive. So this is an engineering challenge for which solutions can be found or have already been found. And it can damage fuel lines, again material problem, and there are solutions for this, and some low vapor pressure problem. So these problems which we face with methanol are actually, most of them are engineering problems, and there are engineering solutions for that. And there are many demonstrations where all these problems have already been tackled. Now, in my opinion, India has gone for methanol economy. This is just a view graph which I made just to explain methanol economy in a very simple way. So any stray carbon that you have in our economy, we have a lot of garbage. Yesterday we saw a mountain at the entry of Delhi. Garbage of the society, the agricultural waste, kitchen waste, high ash coal. We burn a lot of crops which is causing this pollution. All of this is nothing but carbon. So any carbon in the society you have, it's a gold. You basically collect all of that and gasify it and produce carbon monoxide plus hydrogen. Correct the stoichiometry for every carbon monoxide to hydrogen. And in one-step process you can make methanol. From methanol, one-step process you can make DME. And then you can run your entire economy, whether it is transport, whether it is power generation, gensets, any application, you can run your entire economy. So this is in brief what is the concept of methanol economy. Now what I am talking about is not just our fantasy. People are using it. For example, in China, as I mentioned, there are variety of vehicles, all the way from cars to trucks, and they are producing some 40. This is old data, by the way, 10 years old data. 10 years ago, they were producing about 40 million ton every year of methanol. And just to put things in perspective, India consumes about 200 million ton of petroleum products. So it's a very serious quantity. There is a lot of scope. So methanol, DME, and coal to liquid, these are the fuels which can be produced from coal and biomass in a very, very large scale at a very economic point. In China, there are different states and there are different blends, M15, M30, M25. So these are all legal blends. So every state has promulgated and legalized them. So in China, this is legal to sell. In India also now we have issued M80, M15, M85, M100. Now this is already we have done, Niti Aayog and IFCPAR has done a lot of work. It's already legal fuel. And then there are several other countries where this is being explored. In Sweden, there is a plant called Värmlands AB where basically they use wood biomass and convert to 4 lakh liters, which is 400,000 liters per day of biomethanol. In Iceland also, they take the ground energy, geothermal energy, and capture the CO2 from the atmosphere, and they produce about 5.5 thousand tons CO2 they remove, and they produce a lot of methanol. So these are all demonstrated technologies at a commercial scale. So this is all possible. If you have low grade heat available, you can take the CO2 capture from the atmosphere and you can produce methanol. In Edmonton in Canada, there is a plant which converts municipal solid waste into methanol, and they also produce about 400,000 liters per day. And yesterday we saw this. Can't we take care of it? It's a challenge for Terry and other guys, IOC guys. Do something about it. We should have something like this and make our city cleaner. Okay, so India is also working, and I think there are already R&D scale pilot plants have been demonstrated by Delhi and Thermex. 100 ton per day plant is also demonstrated. Now we are moving in the direction of 1500 ton per day plant from coal to methanol. And so this is the production. The cost of methanol production is roughly about 14 rupees 35 paisa per kilogram. And if you take density into account, this is 12 rupees per liter. The Delhi, what is the price of petrol? 95? 100 rupees, and this is 15 rupees per liter. If you take twice the amount, for same energy you are paying 25-30 rupees. For tax, 28%, still 40 rupees. So it makes a lot of sense. And we have a lot of, coal available. So this is the plant which is done by Thermex in Bosham in Maharashtra, and then these are the chemical processes. Somebody wants, I can share this. There are a lot of process plants, how you do it. This is a little bit of a chemical thing. I'm not an expert in this, but I can explain it if somebody wants. And then there are process licensors. It's not a rocket science. Already there are commercial processes available. Standard commercial products from coal to syngas. Standard process license you can get from syngas to methanol production. But coming to engine part, there are a lot of challenges. For example, O-rings, plastic parts, emissions, calibration, cold starting issues, metal parts. So all these are engineering problems, and there are engineering solutions for it. In my lab, Hardik has done a lot of work, and we will. I wish you were in Kanpur. We would have shown you that we have resolved most of these problems. So I'll skip some of these. My time has run out, but to have a methanol based system, we have to look at FIE, which is one of the bottlenecks. Bosch does not support the methanol that much, so we have to look at that part. And then straight development and optimization, something which CAMI does. So this is where a lot of work is required. Combustion, where all of you guys work, combustion characterization, optimization. And then of course there are emissions, whatever unregulated emissions are there. So these are 4 different, if we break this into parts, these are 4 different aspects which we need to look at. And I think the fuel injection equipment remains one of the big challenge in introducing methanol economy in our country. In Europe, there is a lot of interest in marine, and we have the Stina Germanica. There are norms for clean fuels close to the coast, and they have to switch from the conventional bunker fuel to methanol. And this Stina company has at least 15 ships running on methanol, 100% methanol. So I published a paper in Nature India, methanol pollution woes, is methanol a solution? I'll be happy to share the link. Please feel free to download and look at it. So IIT Kanpur is basically focusing on engine development and combustion optimization. There are other things, but Niti Aayog has only assigned us 2 responsibilities, and we are looking at it. And for this, we have developed a motorcycle, 500cc motorcycle, which is a PFI motorcycle. They asked us to provide a solution for small motorcycle, 100 and 125cc, and they said you have to do it in 100 rupees. That means the conversion cost should be $2 for normal motorcycle too. So we did it. And then we did a simulation for locomotive engine where we did 90% replacement. We could not do experiments because the funding was not given. Then we have done a 15 kilowatt genset which runs on M80. Then we have done a car engine with Maruti which runs on M15, and then we have developed a 100% DME tractor all in my lab. These are the pictures of the products that we have developed. So this one cost about, the conversion cost is about $2. This one is about $50. So you can have this PFI, and then the M15 fueled engine, and then we have gensets of all kinds. So these are other products that we are developing, 80% displacement. And we demonstrated them in several places. We also published these books from Springer on methanol. One is for CI engine, the other one is for SI engines. And I think, do we have some of these copies, Hardik? I think we should give it to some of our guests. Okay, so in methanol and DME there is no conflict because they both cater to different disciplines. One caters to SI engine, the other one caters to CI engines, and therefore both can be really looked at. In conclusion, there is no silver bullet, there is no single solution. We have to look at all possible fuels. The problem is mammoth. If somebody says hydrogen can displace everything, that's not possible. If somebody says methanol can displace everything, that's not possible. We have to look at all possible solutions, whatever displacement of fossil fuel we can do, whatever carbon neutrality we can achieve. Let's all try to do that, and it's a very fertile time where technologies should be developed. All kinds of technologies should be developed. We should not say no to anything, because every technology has a space, has a role. And this is my final slide. This is the objective of all of us. IC engines have to survive. They should not be making noise. They should not be visible. They should not be giving visible smoke. They should not be giving any smell. It should be all clean and environment-friendly. Thank you so much. I'm sorry I overstepped. I'll be available for questions if you have any. Otherwise, I am available anyway for 3 days. Yeah.
So this syngas, again you are going to do methanol.
Yes.
So how about doing syngas directly?
Syngas directly, the problem is that it's gas. You can do syngas directly, but how do you store, how do you take it? So you have to transport it.
Because I was looking at it, syngas also can be purified, and then hydrogen content can be also increased.
Yeah, it can be increased, but question is
also can be useful.
Absolutely. If you have a syngas, you put the engine right there. Non-transport application, let's say, perfect, no problem. I think she done a lot of work.
Hello, sir.
But we are talking about transport application. For transport, you need something which is more compact energy. That's why you have to make methanol.
So thank you for your talk. Actually, I have a query regarding the utilization of the hydrogen. Now you mentioned that we can use hydrogen to convert CO2 into methanol. And maximum basically industries, they are looking for the hydrogen to convert CO2 into methanol because that has 2 benefits. We are basically recycling CO2 and then we are using methanol as you mentioned for the thermal application. So is this good to use hydrogen directly for the engine, or is it better way to produce methanol?
Very good question. I understood the question. So let me put it in this way. What is the biggest challenge that we have in hydrogen? One of the biggest challenges that we have in hydrogen is storage. And if you convert hydrogen into methanol, that's one of the best ways to store. You don't need to pressurize. You don't need to do liquefaction. Hydrogen, the problem is the moment you convert to liquid hydrogen, you need to go to 20 Kelvin, minus 253 degrees centigrade. 40% of the energy content is gone just in freezing it. I mean, just in liquefying it. If you compress it to 700 bar for a compressed cylinder, 30% of the energy is gone. So all the energy storage systems are very, very energy intense. Okay, so either we have to develop very efficient systems where the energy penalty is less, or we convert them into either ammonia or methanol. These are energy storage ways in some way. Yeah.
So just one thing, sir. You rightly mentioned at the end that it is not that one fuel which is going to be there. It will be a mixed basket of different fuels, and definitely that is the view of oil companies also, as per the best of my understanding, because we are not going to stick with one particular fuel. So definitely methanol is one such a good fuel for utilization in automobiles. I think based on the study that we have done, we have also introspected what is really happening in that front. Are we going to come up in a large way in methanol blending, something similar to what we do for ethanol? So that is what in our minds also. And typically when we look at the data, as you told very rightly, high ash coal is the very important feedstock. And there are certain challenges as per our understanding in converting into methanol. So hopefully in some point of time, I think that is going to be successful. And then definitely more and more methanol can come from the highest coal of India, because it is anyhow not going to the thermal power plants.
Yes.
I think we hope that that will come as quickly, and that many of those researchers are already going on. So that is what I wanted to tell you. And today's scenario is, sir, if you really look at the methanol sector as a separate sector, today we are consuming somewhere around 2.5 million metric tons of methanol in India for various applications other than automobiles. And the data shows that almost 90% of methanol is being imported even today for India. And that is also one of the reasons. Existing capacities that we have in India are mostly on natural gas based, and because the natural gas cost gone up like anything, and nobody wants to utilize even though existing capacities. I think for that factor about 40% of present capacity is being utilized to produce methanol. And that is something which is really worrying. But hopefully, as you very rightly told, we try to convert more and more coal into methanol, try to bring down the price, try to use it in a large quantity and stop the import what is happening as of now. And slowly and gradually we can go for more and more methanol blending in transportation.
Yeah, let me just respond now. So I think you have rightly said, right now we have 5 companies which are making methanol. 2.5 billion ton, so something like that. It's mostly going in chemical industry, and it is made from natural gas, and their capacity factor utilization is about 50%. Even they are not operating because of the higher gas cost, and gas also we are importing. So that is the current scenario. What we are looking at is coal to methanol. Now let me just tell house about the numbers. So India has proven reserves of 350 billion tons of coal. Remember these numbers. And out of that 300 billion ton, 80 billion ton, which is only 20%, is what is good for use in thermal power plants and steel making. Only 80 billion. 80% we can't use because of high ash. We are consuming roughly about 400 million ton every year. 400 million ton, which is, if we don't do anything, business as usual scenario, that 80 billion ton which is usable is good for us for 200 years. India is not going to phase down coal because that's our only resource. We don't have petroleum. We don't have that kind of petroleum. We will continue to use it. There is no other way for us unless we have some technology breakthrough where solar is able to provide us everything. This 270 billion ton that is left, if we are able to convert that into methanol in an environment friendly way, this will keep us safe for another 1,000 years. That's what we are hoping, and that's what we are trying to build technology for that. So this just, I think, to respond. Economic price point will only happen when you have technology, and I think there is some breakthrough there. IIT Delhi Thermet, they have already done a demonstration plant. BHL Techi is involved. It's just that they have to now upscale it to 1500 million ton. And remember, if we are able to do it, then all our coal power plants which are producing electricity can be converted into gasification. They can be methanol production units. You don't need a separate infrastructure for that. That's another point. I think we can take offline question, or maybe you can quick question, because I think we are already late.
Just one question, Professor. Very nice talk. I remember 20 years ago when I ran diesel engine with DME with Renault, I faced a very strong argument concerning the power, because if you have less heating value, you also lose some power. How have you addressed this point concerning methanol and engine?
See, in diesel engines, we didn't notice any noticeable reduction in power, because only thing is that you have to tune your, you have to recalibrate your fuel injection system. You inject double the quantity, and then maybe you have to optimize your turbocharging if it is turbocharging. So that peak power problem is addressable. It's not really a major issue. It happens if your fuel is gaseous, then the volumetric efficiency will reduce, and then derating will happen. But I think in our lab we did not experience the derating issues of the. Anyway, I think one of the possible reasons what you experienced and what we experienced, the reason is that maybe you are dealing with high IMEP engines, 50-20 bars. We were dealing with the engines which go up to like 10-12 bars. So that could be one of the reasons. Yeah. Quick question? Yeah.
So I wanted to ask a different question, but just for a quick question, I think we also need to do a lot on the direct air capture kind of technology development.
Yes,
in India.
yes, absolutely.
Because all of this will finally need that. And
Net zero can only happen when we do direct air capture.
Yeah, it is only in Germany and some of the places, but we can do a lot. And one more thing I just want to highlight, about this, we tried to work on this area. That is, one is the municipal solid waste, so you are getting the volume at a place together. Going for gasification is easy. But when we talk about the decentralized kind of wastes like plastic and agro residues and other things, in that case, even to bring everything to a gasification plant, central plant, again might do the very detrimental, because again transportation of that. From that point of view, and having the better quality syngas with respect to methanol or DME formation with the CH ratio, so there are some kind of intermediate like pyrolysis and all also we should look at.
Sure, definitely, I agree. Thank you. We can discuss, I'm sure we will have many questions, and we can discuss offline. Thank you.
Long live India and France friendship.